Let's talk about the Ferrari's method, this one. So actually it is used for solving the biquadratic equation with a degree of 4. So let us take an example of this one and solve it right away. I will be trying to do step by step. If not required, I will be jumping. So the first thing we have to do is just to make these two terms vanish away. And to make these two terms vanish away, we will have to take and make them a perfect square. What do you have to do? You have to make a perfect square so that these two terms vanishes away, leaving us with other terms. So what we will have to do is, like, we know that actually this term is x squared whole to the power 2, and this term can be written as minus 2 times of x squared into 6x. So what we have to make this a perfect square, what do we need? We actually need a value like this, and that is obviously a 36x squared, which will be taken from here, and I will add a lambda to adjust, and we have to find the value of lambda later on by equating both sides, and on getting lambda we will actually reduce the equation and get the roots. So I will just add a lambda squared, I will subtract a lambda square, I will add up something like 2ab like that. So 2x squared lambda I need, I have to subtract 2x squared lambda. I also need a negative sign. Actually this 6x, I will take the 6x to be negative. Okay, so I will take 6x to be negative. 6x okay, let us keep that in mind, that I will actually take 6x to be negative. So taking 6x negative, we will have a negative of 12x lambda. So we will have to add up a 12x lambda later on, and as you can see that this is positive, but yeah, this is negative, and we can later on adjust them one by one. So first of all, what we have to do is, this is actually a perfect square. What we are left on this side is a perfect square, and we will adjust this with the respective values, like this is and this are constant. This has a x squared value and this has x squared value. So what actually we have done with the x squared is, we have x squared here, we have x squared here, and we have taken up x squared here. So we will just calculate in our brain and just write it, the equation that has been modified to, like, let me clear up the screen a little, and oops, okay, so we have cleared it up, yeah. And then we will directly write this total perfect square, that is x squared minus 6x, as I have told earlier that I will be taking the 6x term to be the negative one, and a lambda that I have taken earlier on, and it is a whole square, plus actually we were remained up with a 36x squared and a 41, so we have actually 5x squared left, minus 2 lambda x squared, because we have added 2 lambda x squared, so we have to subtract lambda x squared, plus like 12 lambda minus 18 of x, we had negative of, actually we added a lambda square, we will subtract a lambda square, and plus 72 equals to 0. So we need to write this side by side. So what I am going to do is just take this, oops, take this, put it on the side, make this whole equation a lot more shorter. We are actually done with it. Like this, put it in. So actually this is our equation. So what I am gonna do next is, we have this whole term, I will take this whole term on the right hand side. Okay, so actually not this whole term, actually the whole term denotes from here to here, because 0 is not in the whole term. We will take it on the right side. So in writing the equation, actually we have x squared minus 6x plus lambda whole squared is equals, like I'm going to write like change it to 2 lambda minus 1 times x square plus 18 minus square lambda times x and plus lambda squared plus n. What happened is like the signs are only changed, this sign and this sign. So without changing this sign, I just reverted the order, so it keeps the same. And now what we are going to use is that it is a quadratic equation. X squared term is present, x is present and a constant. So what I am going to do is making d is equals to 0. And why I am doing that? Because the left hand side is a perfect square. So obviously if this is an equation, the left hand and the right hand must be the same. So for making it same, this must be d equals to 0 for the right hand side. I'm writing this for right hand side. And by making the discriminant of the quadratic equation 0, we can get the value of lambda, which is like something 18 minus 12 of lambda whole squared. This is the b, like the b square equals to 4ac if you remember, by making the discriminant 0. So this is the b, and which is equals to 4 times 2 lambda minus of 5 into lambda square plus 72. So actually what we are left with is a whole lot of equation with a lot of actually this is a cubic equation. There we have a lambda square, lambda and a lambda square. So this will add up to a cubic equation, which is like 2 lambda power 3 minus 41 lambda squared plus 252 lambda minus 441 is equals to 0. So on further simplifying or using, you can go and use Wolfram alpha just to find the root of lambda, which is basically lambda equals to 3. You can get quite a good root that lambda is equals to 3. I'm not going to solve that whole thing into like what happens here and there. And if we put lambda is equals to 3, we will have the equation reduced to like x squared minus 6x plus 3 whole squared is basically equals to x minus 9 whole square. What I did actually, let me make this a little smaller. It is actually taking up quite a lot of space, which I'm not needed. So let it be. And we have this equation, and this is the required equation. This is the actual required equation, this one. So for the required equation we have that one. So now and how did I get that? Just put the value of lambda here and here and here, you will directly get the value. And so actually next step will be taking this to the LHS again, and what we will be doing like x squared minus 6x plus 3 whole square negative of x minus 9 whole square is equals to 0. So what happened is like this is a square, this is a square. We will apply the formula a square minus b square equals to a minus b into a plus b. This formula applied is quite easy to handle, because we will then equate both the equations to be 0, and then we will have our solutions. Like if we reduce it, it will become x squared minus 5x minus 6 into x squared minus 7x plus 12, which will be getting us to a 0 value. So this will be 0 and this will be 0. From here we can get the two values, and here we will have the two values giving us all four values required. And it is quite useful trick, because when we have quite a big amount of equation, we will be having quite lot of time saving by this method. So it's quite easy method to remember, right? Just the lambda term. It is quite easy than the Cardan's method. There are too many assumptions, too many cubing, and so actually at last we will be having the solution. So let us write down the solutions. The solution is just the roots of the equation. You can verify it by yourself that the roots are minus 1, 3, 4 and 6. I have solved it and got these 4. Check it. if you don't believe me, because I had checked it from my father. Yeah, it's right. So thank you.